Okay, so Unit 1 review. So number 1 says, what method of data collection would you use to collect data for a study where a drug was given to 46 patients and a placebo was given to the other group of 46 patients to determine if the drug has an effect on a patient's illness? We want to know if it's designed experiment or an observational study. So here, the fact that we are giving people a drug and a placebo, we are doing something to the patients that makes it an experiment. If we were just watching something that was already happening, we didn't give them a drug. If we were just trying to see like what their symptoms were doing or what their illness was doing to them, that would be a study. But since we're giving them a drug to try to see how that drug will affect them, that's the designed experiment. So A is the correct answer for 1. Number 2, what method of data collection would you use to collect data for a study where a political pollster wishes to determine if his candidate is leading in the polls? So here, we're not doing anything to the people. All we're doing is asking them questions like who would you vote for? So this is just an observational study. We're just gathering information from people. We're not applying any sort of treatment to them. So A is correct. Number 3, the city council of a small town needs to determine if the town's residents will support the building of a new library. The council decides to conduct a survey of the sample of the town's residents. Which of the following procedures would be most appropriate for obtaining a sample of the town's residents? All right. So A, survey every 15th person who enters the old library on a given day. It is every 15th, which is systematic, which is good. However, we're only doing it to the people that come into the library. So it's going to be kind of a biased opinion. If you're only getting people who actually use the library, they're going to be more likely to want to use a new library as well. So that's going to be a little biased here. So probably not letter A. Letter B. Survey 400 individuals who are randomly selected from a list of all people living in the state in which the town is located. Again, here it is a random sample, which is good, but we're talking about all the people living in the state. If we just are talking about a new library in this town, chances are people in other cities or other towns in the state are not going to have much of an opinion on whether this random town gets a new library. So again, the population that they're choosing from is just too big and too vague, so it's probably not going to be letter B. Letter C, survey a random sample of persons within each neighborhood of the town. So here, random sample of persons is good, and it's in each neighborhood of the town. So we're good. We're going towards the right track. Letter C looks promising. Let's look at letter D. Survey a random sample of librarians who live in the town. Again, random is cool, but we're talking about librarians who obviously are going to want a nice new place to work. So that, again, is going to be biased. So C is the correct answer. Number 4, every 5th teenager entering a concert is checked for possession of drugs. What sampling technique is used? So here, every 5th, that is systematic. So C, whenever you're doing counting by a certain number every time. Number 5, 35 sophomores, 29 juniors, and 39 seniors are randomly selected from 583 sophomores, 447 juniors, and 250 seniors at a certain high school. What sampling is this? So here they took some people from each group. So first they divided into groups, right, by grade, sophomores, juniors, and seniors. So the two that divide into groups are stratified and cluster. So we've narrowed it down to those. And then since we took some from each group, that is stratified, which would be letter B. Cluster would be if we randomly chose entire grades, like we randomly took all the juniors and all the seniors. Okay, number 6, a local community college. 5 statistics classes were randomly selected, and all of the students from each class were interviewed while sampling technique is used. So we talk about classes, which are groups. So again, the two that divide into groups are either stratified or cluster. And then here we are randomly selecting classes and taking all of the students from each class that's chosen. That's going to be cluster, which would be a letter B. Number 7, a lobbyist for a major aerospace firm assigns a number to each legislator and then uses a computer to randomly generate 10 numbers. Lobbyist contacts legislators corresponding to these numbers. So here we're not dividing anybody into groups, we're not counting by a certain number, and we're not letting people choose. So since we're not doing the groups, we know it's not cluster or stratified. We're not doing like every 6th or every 7th person, so it's not systematic. And we're not giving people a choice. We are choosing who to ask. We're not giving our sample people a chance to choose. So that automatically leaves random, and that's because here the computer is randomly generating those numbers, which makes it random. So B is correct for 7. Number 8, a community college student interviews everyone in a statistics class to determine who in the college owns a car. What sampling technique is used? So here we want to know about everybody in the college. but this student is only asking people in a statistics class, just one statistics class. So one class is not going to be a good representation of the entire college. He's being lazy in who he asks, which would make this a convenience sample, which would be letter B. A survey of 1348 American households found that 48% of the households own a computer. Identify the population, sample, and individuals. So remember, the population is the big group, the all. This would be all American households. The sample is the number of people you're actually taking for your experiment or survey. So this would be the 1,348 American households. Oops. And then the individual is just one person or one thing, in this case a household. So the individual would be each or one American household. So again, population is all, sample is a number, and individual is each. All right, number 10. Clothing store wants to know if its customers are satisfied with the service they receive. The store posts an interviewer at the front of the store to ask the first 60 shoppers who walk into the store how satisfied on a scale of 1 to 10 are you with the store's customer service. Determine which survey design or whether the survey design or the sampling method is flawed. So here, this question that they're asking, how satisfied on a scale of 1 to 10 are you with the store's customer service, is pretty good. The question itself is fine. However, the issue comes with the sampling method. There's like two things that are wrong here. First, they're just asking the first 60 people, so they're not getting a good spread of customers throughout the day, which makes it a convenience sample. But then also, they're asking them as they walk into the store before they've even experienced their shopping in the store. So that's also not good as well. So before they even shop. So again, that would be the sampling method that's flawed. The survey design, the question itself is fine. It's just how they're going about asking it. Okay, 11. Before opening a new branch, a car insurance company wants to gather information about car ownership and driving habits. They randomly select 1,000 households from all households in the area, mail a questionnaire to them. Of the 1,000, she receives 95 back. Here, again, I'm sure the questionnaire, we don't really have much information about what the questions actually said, so we can't really say if the survey design was flawed or not. But here, the fact that only 95 out of 1,000 responded, that means the sampling method is flawed. It was a convenience survey because it had a high non-response rate. A lot of people didn't respond. So high non-response. All right. Number 12, multiple choice questions on a test that include none of the above as one of the choices are an example of what type of question. Multiple choice is always going to be the closed-ended, so letter C. The types of questions are closed and open. Closed is multiple choice. Open is short answer where people can write in whatever they want. The fact that we just include this little part about none of the above doesn't change anything. It's still a multiple choice question. Number 13, the variable measured in the experiment is called. So the thing that we are measuring in order to answer our question or test our claim is called the response variable. We're trying to see how this thing responds to whatever treatment we are applying. So A would be correct. 14, blank is a condition applied to the experimental units involved in the experiment. That would be the treatment, the thing that you are introducing, so like the new drug or listening to music while testing or something like that. All right, 15, we've seen this problem a lot of times. Our corn yield, where we divide up our plots here. But the question is asking what is the claim. And the claim is the thing that you're trying to test with this experiment. And so here it says, the salesman boasts to a farmer that his new fertilizer will increase the yield of a farmer's crops by 15%. And so that means that what we're trying to test here is that it will increase the yield by 15%, which means that would be, letter B. fertilizer yielded at least a 15% improvement. You got to say the new fertilizer, the thing you're trying to test, and then what the goal is, the thing you're trying to find out if it actually works. Then number 16, a drug company wanted to test a new arthritis medication. They found 600 adults, randomly assigned them to two groups. First group got the new drug, second group received the placebo. After 1 month of treatment, percentage of each group whose arthritis symptoms decreased was recorded and compared. So what is the response variable? So again, response variable is what you're measuring, or after you apply your treatment, what you're going to be looking for, what you're going to be checking, what data you're going to be gathering. And so here it was the percentage of each group whose arthritis symptoms decreased. So that would be letter D. And 17, here's our soil one again, this time with tomatoes. So we divide each of the different soils into 4 plots, or each of the 4 plots into 3 sections, A, B, and C. That all the A's get the old fertilizer, all the B's get the new fertilizer, and all the C's get no fertilizer. We want to know what is the response variable. Again, what are you measuring? In this case, we are recording the tomato yield is recorded. That's how you know it's the response variable, whatever you're recording. So tomato yield recorded for each section of the land. That'd be letter A. And our soil again. What is the treatment, though, this time? This is what are you applying to your subjects, in this case, our tomato plants. And here we're doing the different fertilizer. So the different types of fertilizers, the old one, the new one, and the no fertilizer. So that'd be letter C. 19, still with our soil and our tomatoes. How many levels does the treatment have in this experiment? Again, we're just talking about the treatment, so what are you doing to your individuals or our tomato plants? And again, our treatments we set up here were the old, the new, or none. That's 3, so we have 3 different levels. So letter A. And our last one, still with this tomato yield. What type of experimental design? So remember, experimental design is how you're setting up an experiment that's different than the sampling methods. So the 3 that we actually have listed here, these are the only 3 types of experimental designs that we have learned: randomized, block, matched pairs, and completely randomized. So let's kind of diagram what they did here. So we have our different soil. We have the sandy soil, we have the rocky soil, we have clay-rich, and we have average. And then within each of these soils, we split it up into A, B, and C. So sandy has an A, B, and C. Rocky has the A, B, and C. Clay-rich has A, B, and C. And the average has A, B, and C. And then within each of those types of soils, all 3 of the treatments, the old fertilizer, new fertilizer, no fertilizer, were randomly assigned to those A, B's, and C's. So like we had new, old, none. Or old, new, none, etc. So all of them, each type of soil had all of the treatments. This is the randomized block design because we split up our individuals into blocks first, which is the type of soil. And then within each block, we randomly assigned all the treatments. Remember, matched pairs is like the before and after type of experiment, or if you have 2 people with similar characteristics, like identical twins are used a lot. One gets the treatment, one doesn't, and you compare. Or completely randomized design would just be if you took all the soil and randomly gave the different plots the different types of fertilizer. So you didn't divide it into blocks first, so like we wouldn't care necessarily what the different types of soil were. That would be completely randomized. If you just took all your land, split it up into 3, and did your treatments that way. And that is the Unit 1 questions.